project consists of 121 northbound and southbound bridges. The whole element of this project came about because the Chisholm Parkway is running right through here.
When the Austin Bridge and Road team bid on the Southwest Parkway 2B job through Central Fort Worth, Texas, they knew they would be faced with a unique coordination challenge: hoisting and assembling 8 sets of multi-section beams, spanning over 250 feet and weighing almost 90 tons each, from a work site in the midst of one of the busiest rail yards in the country.
Well, when we recognized right off the bat that these bridges were going right through the middle of this busy rail yard, we started trying to identify what we could do and what we could not do with the tracks and the trains still running through the yard.
The job spanned the Union Pacific Railroad's expansive Davidson Yard, the Trinity River, and also included constructing a new Hewlin Street Bridge in one of the busiest areas of the city.
We had to be inside the rail yard and finish our work within a year. And so we really had to look and make sure that our sequencing and how we were going to do this and how we were going to plan this work was actually feasible to meet our 1-year schedule to get in here and then get out.
After being awarded the bid, the Austin Bridge and Road project team evaluated the building sequence for the entire 2B project that had already been put in place by the project owner, the North Texas Tollway Authority, along with the Union Pacific Railroad, and identified some feasibility issues that needed addressing.
With building 3 bridges through a busy rail yard, there's going to be challenges and there's going to be better ways to do things, better opportunities to ensure not only your success on the project, but the owner's success, and that the rail yard is happy with what you're doing. You're not interrupting their flow of the trains that have to come through this yard.
A series of meetings between Austin Bridge and Road team members and the Union Pacific Railroad resulted in a modified approach: top-down construction, building the tallest structure first. This allowed the Hewlin Street Bridge to be opened sooner and relieve construction-related traffic issues earlier than would have been possible originally. The N4 span would go under the newly built Hewlin Street Bridge and over a temporary hump lead feeding into the rail yard. A hump lead is a raised portion of the track which is used to sort rail cars by decoupling them and letting gravity provide the downhill momentum force needed to recouple them on specific tracks.
The hump lead's the main artery for the Union Pacific Davidson Yard here, where all the trains that come into this facility get redispatched to the different portions of the United States. See where the train is now moving, we have a 4-hour window once a week to work on it. And then 2 of these other tracks, we have 1 hour and 45-minute windows throughout the course of a day to work over it.
With train traffic moving in both directions, the large cranes would be working in tight quarters, moving materials carefully into place with little time for error. It was a perfect storm of challenges, and careful planning and coordination were critical to meet the scheduling goals.
It's very challenging to work around and complete this work in that 4-hour window. It takes a lot of planning and scheduling for beam deliveries and personnel. You have to work multiple tasks at the same time. Basically, you had to get everything prepped and the beams on the hooks of the crane ready to go, so when you got your window of opportunity to work, you could minimize your time over those 3 tracks.
For the construction of N4, 24 beams were trucked in, lifted into place, and set. Each beam assembly included 2 short beams and 1 long beam. The 3 beams had to be air spliced together. In preparation for beam placement, shoring towers were built to support the first beams placed. Then cranes were erected and moved into position. Steel bearing pads, which were used to support the ends of the beam assemblies, were lifted and secured. The beams then were trucked onto the worksite and maneuvered into place, ready for lifting. Then, when a scheduled break in hump lead traffic began, the teams were ready to lift the first beam and place it on the cap and shoring tower. Once this beam was secure, trains started moving again.
Setting the lower span is often challenging because your cranes need the headroom. They have the rigging that's necessary for the beams, their block, and their booms that have to go well above the span that they're setting. And so when you set that upper span, you eliminate a lot of that headroom that's needed.
The tight spacing of the N4 span called for expert operators and an experienced crew. Since the top-down construction of the new Hewlin Street Bridge had already been completed, there was now limited clearance for the cranes to move when they were picking up and placing the beam. At the same time, the space between the railroad tracks dictated the limitations of crane placement. But the skill levels of the operators and crew kept the process moving smoothly. After 20 days, the 8 beam assemblies were in place and awaited the next phase of construction. With the N4 beams in place, work could continue on other aspects of the project for several more months.
Key planning and recognition of opportunities and execution of the work plan is just essential and paramount.
In the case of the N4 beam placement, the team at Austin Bridge and Road accomplished a common task, but in a very uncommon situation. In each major project, unique challenges arise. Solutions to complex issues require the knowledge and experience that only a track record of success can provide, which is why Austin Bridge and Road is looked to as a leader within the road and bridge construction industry.